Hello, I'm Bhuwana Basapur, and I'll be talking about data augmentation techniques in NLP. To develop a good machine learning model, the most important necessity is availability of good quality data. By good quality here refers to a fairly uniform distribution of data of all varieties. To help alleviate this problem of scarcity of data, a technique called data augmentation is widely being used. In simple terms, data augmentation is creation of synthetic data without directly collecting more data. It encompasses methods used to increase the amount of data by adding slightly modified copies of already existing data or newly created synthetic data from existing data. Data augmentation is widely applied in field of computer vision like flipping and rotation, and it was later introduced in the NLP field as well. Many methods to implement data augmentation have been proposed recently, and the three main categories are paraphrasing, noising, and sampling. The main thrust of DA effectiveness is to improve the diversity of training data. So, to facilitate this, uh, data augmentation can be broadly categorized into paraphrasing, noising, and sampling. Paraphrasing, it generates paraphrases of the original data as augmented data. It brings very limited changes when compared to the original data. For example, if we look at this picture, there's a picture of a man standing with a white shirt and a blue pant. And it says a person in white clothes and jeans is standing there. Using paraphrasing, it would be changed as a person in white sweater and jeans is standing there. Second method is noising. Noising adds continuous or discrete noise to the original data and it involves more changes. And for the example here, it'll be changed as a person, people in white sweater and jeans there. The third method is sampling, where sampling masters the distribution of the original data to sample new data as augmented data, and it can generate very diverse data. So in this example, it'll be changed as there stands a girl wearing white sweater and jeans. Let's look at each of these in detail. First is paraphrasing. Paraphrases are alternative words used to convey the same information as the original word. Paraphrases in natural language can be generated in three levels, including word level, phrase level, and sentence level. So let's look into each of these examples in paraphrases. The first one is Thesaurus. Some works replace the words in the original text with their true synonyms or hypernyms so as to obtain a new way of expression while keeping the semantics of the original text as unchanged as possible. WordNet, a famous lexical database of semantic relations between words, sorts the synonyms of words according to their similarity. So, for each sentence, all replaceable words are retrieved, and a certain number of words are randomly chosen to be replaced. Choosing the value of the number of words to be replaced can be determined by using either a geometric distribution or it can be a random number. Instead of synonyms, hypernyms can also be used to replace some original words. Another lexicon called as VerbNet, which is a broad coverage verb lexicon, can be used to retrieve synonyms, hypernyms, and words of the same category. The advantages are it is quite easy to use, but the scope and part of speech replacement words are very limited. This method cannot solve the problem of ambiguity, and the sentence semantics may be affected if too many replacements occur. The next one is semantic embeddings. This method overcomes the limitation of replacement range in word part of speech in the thesaurus-based method. It uses pre-trained word vectors such as glove, word-to-vec, fast text, etc., and replaces them with the word closest to the original word in the vector space. Instead of using just discrete words, either words, word embeddings, or frame embeddings, or both can be used to replace words. For word embeddings, each original word in the tweet or sentence is replaced with one of the k nearest neighbor words using cosine similarity. For example, being late is terrible will become being behind is bad. As per frame semantic embeddings, the sentences are parsed and continuous bag of frame model to represent each semantic frame using word to vec will be developed. Thesaurus can also be used in conjunction with embeddings for balance. The advantage is it's quite easy to use and higher replacement hit rate and wider replacement range. The limitation is this method cannot solve the problem of ambiguity, and the sentence semantics may be affected if too many replacements occur. Next is language models. Here, the pre-trained language model, which has become a mainstream model in the recent years due to its excellent performance. Masked language models or MLMs such as BERT and Roberta have obtained the ability to predict the masked words in the text based on context through pre-training, which can be used for text data augmentation. This method alleviates the problem of ambiguity since masked language models consider the whole context. To obtain task-specific distillation training augmented data, BERT tokenizer is used to tokenize words into multiple word pieces and form a candidate set for each word piece. Both word embeddings and masked language models are used for word replacement. Specifically, if a word piece is not a complete word, for example, words ending with est, the candidate set is made up of its k nearest neighbor words by glob. If the word piece is a complete word, the authors or we can replace it with mask and employ BERT to predict k words to form a candidate set. Finally, a probability of random number, say 0.4, will be used to determine whether each word piece is replaced by a random word in the candidate set. The advantage is it alleviates the problem of ambiguity and it considers context semantics. But the limitations are it is limited to the word level and sentence semantics might be affected. The next method is rules. This method requires some heuristics about natural language that ensure the maintenance of sentence semantics. One can use regular expressions to transform the form without changing the sentence semantics, such as abbreviations and prototypes of verbs, modal verbs, and negation. For example, we can replace is not with isn't. Also, we can perform replacements from expanded to abbreviated form and inversely between a group of words and the corresponding abbreviations relying on word pair dictionaries. Another way is to change the voice of a sentence by building a dependency tree. For example, Sally embraced Peter excitedly can be replaced with Peter was embraced excitedly by Sally. A syntactic parser can be used to build a dependency tree for the original sentence. Then the paraphrases generator transforms this dependency tree to create a transformed dependency tree guided by transformation grammar. The transformed dependency tree is then used to generate a paraphrase similar to the augmented data. Rules is quite easy to use, and this method also preserves the original semantics. But the problem is it requires artificial heuristics and it has a very low coverage and limited variation. Next is machine translation. Translation is a natural means of paraphrasing. With the development of machine translation models and availability of online APIs, machine translation is popular as augmented method in many tasks. Machine translation can be further categorized into back translation and inverse translation. Back translation, what back translation means is that this method, the original document is translated into other languages and then translated back to obtain the new text in the original language. It is different from word level methods because back translation does not directly replace individual words, but it rewrites the whole sentence in a generated way. In addition to some trained machine translation models, Google's Cloud Translation API service can also be used as a tool for back translation. Back translation can also be combined with adversarial training to synthesize diverse and informative augmented examples by organically integrating multiple transformation. The second one is unidirectional translation. It is different from back translation in the way that the unidirectional translation method directly translates the original text into other languages once without translating it back to the original language. This method usually occurs in multilingual scenes. This technique can be applied to unsupervised cross-lingual word embeddings or CLEW tasks where an unsupervised machine translation model is first trained on the source or target training corpora and then translated using UMT model. The machine translated corpus is then concatenated with the original corpus for the learning of monolingual word embeddings independently for each language. Finally, the learned monolingual word embeddings will be mapped to a shared CLWE space. This method both facilitates the structural similarity of two monolingual embedding spaces and improves the quality of CLWEs in the unsupervised mapping method. The advantage, it is quite easy to use. It has a very strong applicability. This method ensures grammar and is correct and the semantics remains unchanged. But the limitation is that it has a very poor controllability and it has limited diversity because of fixed machine translation models. Next is model generation. Sequence to sequence model are employed to generate paraphrases directly. These models output more diverse sentence given proper training objects. One way to implement this is by feeding the delexicalized input in the specified diverse rank K, say 1, 2, 3, into the sequence to sequence model as input and to generate a new input, or use transformers as the basic structure where the masked original sentences as well as their label sequences are used to train a model that reconstructs the masked fragment as augmented data. The advantage is it has a strong diversity and a very strong application, but it requires very high training data and it has a high training difficulty. Next method is called noising based method. The noising based methods add faint noise that does not seriously affect the semantics, unlike paraphrasing, so as to make it appropriately different from the original data. We can greatly reduce the impact of weak noise on semantic understanding through the mastery of language phenomenon and prior knowledge. But this noise may bring challenges to the model. Thus, this method not only expands the amount of training data, but also improves model robustness. There are different methods: swapping, deletion, insertion, substitution, and mix-up. What is swapping? Swapping, the semantics of natural language is sensitive to text order information, and slight order changes, though it is still readable to humans, it is quite different than the original. Therefore, random swapping between words and even sentences within a reasonable range can be used as a data augmentation method. We can choose two words in a sentence and swap their positions and repeat this process n times, and n should be proportional to the length of the sentences. Another way is to split the token sequence into segments according to labels and then randomly choose some segments to shuffle the order of the tokens inside with the label and order unchanged. Next is deletion. This method randomly deletes words in a sentence or deletes sentences in a document. In word level deletion, words with random probability P are chosen for deletion. Similarly, sentences in a document can be randomly deleted. Next is insertion. In this method, it is quite similar to deletion. Instead of deleting, random words in the sentences are selected and its synonyms are inserted in random places and it is repeated many times. At sentence level insertion, random sentences of the document are chosen and sentences with the same classification from other documents are also added at random places. Next is substitution. This method randomly replaces words or sentences with other strings, but it usually avoids using strings that are semantically similar to the original data, and that's how it's different from paraphrasing. It can be implemented by substituting through existing outer resources like a list of most common misspellings in English and generating augmented text containing misspellings. For example, across is usually misspelled as ACCROSS instead of ACROSS. Another way is to replace original words with other words in the vocabulary using TF-IDF value and the unigram frequency to choose words from the vocabulary. Another way is multilingual code switching method, which replaces original words in the source language with words of other languages. Next is mix-up. This technique is mostly used for classification tasks and works by performing interpolations on the original dataset. There are two possible variants. The first one is word mix-up, which conducts sample interpolation in word embedding space. And second is sentence mix-up, which interpolates the hidden states of the sentence encoders. The next one is sampling-based method. The sampling-based methods master the data distribution and sample novel points within them. Similar to paraphrasing-based models, sampling-based methods also involve rules and train models to generate augmented data. The difference is that the sampling-based methods are task-specific and require task information like label and data format, and paraphrasing methods are task-independent and only require original sentences as input. The first type is rules. This method uses some rules to directly generate new augmented data, like swapping the subject and object of the resource sentence and converting the predicate verbs into passive form. For example, this small collection contains 16 El Grecos would be changed to 16 El Grecos contain this small collection. The heuristics about natural language and corresponding labels are sometimes required to ensure the validity of the augmented data. The advantage is it's quite easy to use, but this method requires artificial heuristics and it has a low coverage and limited variation. Next is sequence-to-sequence models. Some methods use non-pre-trained models to generate augmented data. Such method usually call for the idea of back translation, which is to train a target to source sequence to sequence model use that model to generate source sentences from target sentences, that is, constructing pseudo parallel sentences. Such sequence to sequence model learns the internal mapping between the distribution of the target and the source. This is different from model generation based method because the augmented data of the paraphrasing method shares similar semantics with original data. The advantage is it has strong diversity and strong application, but it's similar to paraphrasing method. It requires high training data, high number of training data, and it has high training difficulty. The next one is language models. In recent years, pre-trained language models like GPT-2 have been widely used and have been proven to contain knowledge. Thus, they can be naturally used as augmentation tools. Pre-trained models like SAGPT, SAGPT NLU, and Distilbert can also be used to generate augmented data, that is, generating synthetic sentences. Amongst all the pre-trained models available, GPT-2 is the most used model for data augmentation. The advantage is it has got strong application, but it also requires large amount of training data. The next one is self-training. In some scenarios, unlabeled raw data is very easy to obtain. Thus, converting such data into valid data will greatly increase the amount of data. One way is to train and fine-tune a model like BERT on a golden data set and use the fine-tuned model to generate labels for the unlabeled data. This augmented data, along with the golden data set, combined can be used to train another model like SBERT, and it's similar to student teacher model. Another way is to directly transfer existing model from other tasks to generate pseudo-parallel datasets like transport learning. The advantage is it's very easy when compared to generative models, and it is suitable for data sparse scenarios. But the disadvantage is it requires unlabeled data and has got very limited application. Next, we're going to analyze all these methods. This table denotes different parameters. Here, learnable denotes whether the method involved model training. Online and offline denote learning. Offline and online denote online learning and offline learning respectively. Extension no refers to whether the methods require external knowledge resources to generate augmented data. Pre-trained denotes whether the methods require a pre-trained model. Task-related denotes whether the methods consider the label information, task format, and task requirements to generate augmented data. Level denotes the depth and extent to which elements of the instance or data are modified by the data augmentation. T and A and I denote text, embedding, and label respectively. Granularity indicates the extent to which the method could augment. W, P, and S denote word, phrase, and sentence respectively. If we analyze this, it is easy to find that nearly all paraphrasing-based and noising-based methods are not learnable except for sequence to sequence and mix-up. However, most sampling-based methods are learnable except for the rule-based ones. Learnable methods are usually more complex than non-learnable ones. Thus, sampling-based methods generate more diverse and fluent data than the former two. Among all learnable methods, mix-up is the only online one. That is to say, the process of augmented data generation is independent of downstream task model training. Thus, mix-up is the only one that outputs cross-label and discrete embeddings from augmented data. Comparing the learnable column and the resource column, we could see that most non-learnable methods require external knowledge resources which go beyond the original dataset and task definition. Commonly used resources include semantic thesauruses like WordNet and PPDB, handmade resources like misspelling dictionary and artificial heuristics. Combining the first three columns, we could see that pre-trained and non-pre-trained models are widely used as data augmentation methods in addition to external resources. It is because the knowledge in pre-trained models and the training objects play a similar role to external resources when guiding augmented data generation. Comparing the learnable column and the task-related column, we could see that in the two categories of paraphrasing and noising, almost all methods are not task-related. They could generate augmented data given only original data without labels or task definitions. However, all sampling methods are task-related because they adopt heuristics and model training to satisfy the needs of specific tasks. Comparing the level column and the task-related column, we could see that they are relevant. The paraphrasing-based methods are at the text level. So does the noising-based methods, except for mix-up, because it makes changes in the embeddings as well as labels. All sampling-based methods are at the text and label level, since the labels are also considered and constructed during augmentation. Comparing the learnable column and the granularity column, we could see that almost all non-learnable methods could be used for word level and phrase level data augmentation, but all learnable methods could only be applied for sentence level data augmentation. Although learnable methods generate high-quality augmented sentences, unfortunately, they do not work for document augmentation because of their weak processing ability for documents. Thus, document augmentation still relies on simple non-learnable methods. Thank you.